It's important for us to reactivate what students already know about base 10 materials. When they used those in elementary school, they knew why each one had its name in different contexts. Often, the smallest piece is called a 1 because we define it as having dimensions of 1 by 1 by 1. The rod is often defined as a 10 because it has a volume that is 1 by 1 by 10, or a volume of 10. The 100 flat, we call it that because it has a volume of 100. It's 10 by 10 by 1. And if we stack 10 of those together, we can make a cube that is 1,000. Once we've redefined that with students, we want to put those materials on everyone's desks. This gets rid of the stigma that only some students need manipulatives. We know that manipulatives are an important tool for learning math, and that many students, all students, begin their understanding in the concrete. So then once we've got these materials on students' desks, they know what each piece means, we're going to ask them to represent their understanding of 12 multiplied by 3 in as many ways as they can. Students might not know what we're asking them to do here. We're asking them to really represent their understanding of the meaning of multiplication, and it's really important we give them some wait time and we allow that productive struggle to happen. While that's happening, we're circulating around our classroom because we're looking for student work that we can use to pull out the important ideas about multiplication. Pause the video and try this yourself. How many different ways can you represent 12 multiplied by 3? When we look at student work, often we'll see these two representations. On the left, we see 3 multiplied by 12, or 3 groups of 12. And on the right, we see 12 multiplied by 3, 12 groups of 3. And it's really important to get excited about this and to name it for students and let them know this is the commutative property of multiplication. It doesn't actually matter which order those numbers are in. We're still going to get to that same answer of 36. But we need to move past groups of models into a model that's going to take us into grade 10 quadratics. And so when we see students that have a groups of model that looks like this, we might ask some questions to nudge them towards another model. We might say, can I push these close together? Or we might say, could you turn those into a rectangle? We get this. And now we've got a rectangle. We know about the properties of rectangles. We know how their length and their width and their area are related. And we can see here that the width is 3 and the length is 12 and the area is 36, giving us the answer to that multiplication problem. Once we've really settled on this area model, we're going to ask students to practice that with a harder problem. So we're going to ask them to represent 12 multiplied by 23. Again, we're going to have to give them some time for productive struggle. We're going to use that wait time. It's going to be a little uncomfortable. And a lot of students are going to start with 12 groups of 23. And if we limit their materials, or if we see that they're getting frustrated, we might remind them about what we figured out last time, that we can actually represent multiplication as an area model. And with some wait time and some productive struggle, students will get to this. And they will be able to show us that this is a rectangle who has a width of 23, who has a length of 12, and if we count up all those pieces, we can see that the area is 276. Well, how do we know? Well, if we look at the area model, we can easily count the hundreds, we can count the tens, we can count the units, and we can quickly total up. That's 100, 200, 20, 40, 76, 276. And now we have a model that can take us past double-digit, triple-digit multiplication and into quadratics. We want students to be able to go back and forth between the factors and the product. So we might next ask a question like this. Now you have a given area. Can you use those materials to make a rectangle and find out what the length and width of that rectangle are going to be? And with some time and productive struggle, we're going to see students build perhaps this, which has an area of 120. That's where they began. They pulled out 120 more, and they turned it into a rectangle and found that it had a length of 12 and a width of 10. They might find some other factors of 120. You can have a really great conversation about how they're all correct representations of that multiplication fact. And you're just going to keep practicing back and forth multiplication and factoring, maybe 121, 264. You can choose the numbers that are going to help your students really understand the area model of multiplication.